Hello. Write down the direction vector and name the specified coordinates on the following line. We have points of intersection with OX and OY, and we have R as defined here. Now, our general formula for R, if you look at my previous videos, is A, the position vector, and lambda D. So we can see here that the vector multiplied by lambda is the direction vector. So we can write D is the I coordinate is the X, or the coefficient of I is the X coordinate, and the coefficient of J is the Y coordinate. That's our direction vector. Now we look at the point of intersection of OX and OY. We have Y, X, O, here. And so this is the point of intersection here. And we need to find two values of lambda in order to determine our points of intersection, or the specified coordinates on the line, which is OX intersecting with OY. So first, we can set I to 0, and it allows us to find one of the values of lambda. So we'll have that 1 and 7 lambda is equal to 0. This implies that lambda is equal to minus 1 over 7. We make this 0, then all we're left with, and this 0, all we're left with is the coefficient of J is 1 here, added to 7 times lambda. And we set that equal to 0 because we're saying Y is equal to 0 for this. So next we set in J to be 0, and we can find our next value of lambda, which gives us 4 and 3 lambda is equal to 0. This implies that lambda is equal to minus 4 over 3. Now we have two values of lambda. We can find specified coordinates on the following line given here. Right. We have our two values of lambda, and here is what R is defined as, position vector times added to lambda times the direction vector. So we'll use the first value of lambda, which is minus 1 over 7, and we'll substitute in R. So 4I at J. Now this becomes minus 1 over 7, 3I at 7J. Now this becomes 4I minus 3I over 7. I urge you to go through this step by step. This is J, by the way. No, I, sorry. Please go through this step by step. And we can write this as 28I over 7 minus 3I over 7, which gives us 25I over 7. Now this implies that our coordinates this is the X coordinate, and so we have Y set at 0, because remember it's the intersection of OX and OY given here, point of intersection. So our coordinates with lambda being minus 7 is 25I over In fact, we will not, we'll just use the coordinates. We're not talking about including the unit vector. So it's 25, well, it's 25i over 7 here, but we use the coordinates 25 over 7, the coefficient of the I component. Similarly, with the other value of lambda, which is minus 4 over 3, we have 4i at j minus 4 over 3, 3i, 7j. And this simplifies, gives 4i at j minus 12i over 3 minus 28i over 28j over 3. And this simplifies to give us 3j minus 28j over 3, which is minus 25j over 3. Now, with lambda being minus 4 over 3, the coordinates here, now we have the x being 0, or the I component being 0, and we have the y component as minus 25 over 3. So there you have it. We've calculated both the specify for the points of intersection of OX and OY. We've named the specified coordinates on the following line, which is 25 over 7, 0, and 0 minus 25 over 3. Thanks for watching, and please subscribe to watch more videos. Bye for now.